if we saw Homo erectus from 1.9 million years ago and dressed him up in a nice suit, you know, he would do fine at most of the meetings I sit in. You know, he would just have to nod. And yet we've created this world around us that's so inconceivable in light of that history. You know, when you ask somebody to dream about the future, they very rarely even think about the living future other than humans. You know, it is a future of humans and machines. And the living world, you know, doesn't care what we think about the future. It will be there regardless. As humans, our default response to these changes is to wait until there's an emergency and then to respond. And as I think COVID taught us, it doesn't work very well. But we can anticipate a lot of these changes, but it means we need to make the requisite policy changes now. You know, it needs to be happening now.
Dear all, we are about to begin the third season of Nature of the Future, a series of conversations with writers and scientists with whom I try to imagine what might happen in the near or distant future in the most important areas of our lives. We are not doing futurology here, but simply analyzing data that is available today. My name is Grzegorza Jankowicza. I'm the program director of the Conrad Festival, and my guest today is Rob Dunn. Rob is a professor of ecology at North Carolina State University. Two of his books have been translated into Polish. Never Home Alone, a book about the natural history of the creatures we share life with, and A Natural History of the Future. The latter one will be the most important for us today. I couldn't help but invite the author who wrote The History of the Future to talk about the nature of the future. Hello, Rob.
Oh, it's so great to be able to talk with you today.
I'm very glad that you are here with us. We must begin by explaining the paradox in the title of your book. History is a story about what has happened, not about what is yet to happen. So how can we understand the title of your book? What is the natural history of the future?
So when ecologists think about natural history, we think about the study of the stories of living organisms. And they're often stories embedded in the past. But those stories reveal to us general truths about the way the living world works. And so the book is really about, as we understand those histories, those stories of the living world, what do they tell us about the stories of the living world in the future? And I think one of the biggest things they tell us, and if we listen to them, and we're not very good at listening to them, is that no matter how technological the future becomes, we will still remain embedded in the rest of the living world, and we will still be subject to its stories and subject to its rules. And so that's the biggest idea of the book, which in some ways is very simple. It's a reminder that we are part of the living world. But the technological future, the AI future, the robot future, the spaceship future is so loud that the idea that we're still connected to the natural world, it is very remote from our planning. It is remote from our daily experiences. And it's remote from our dreams. You know, when you ask somebody to dream about the future, they very rarely even think about the living future other than humans. You know, it is a future of humans and machines. And the living world, you know, doesn't care what we think about the future. It will be there regardless. And so that's the way in which that history comes into the future, but also in the sense that the history of the living world is almost 4 billion years old, and the future of the living world will be far longer than us. And so it also broadens that frame to remind us that we're part of something. We are not that something.
I will ask you about this relationship between technology and nature in the future a little bit later. Now I would like to ask you about the intro to your book. You write about our attempts to control rivers, and one river in particular, which I already discussed here a year ago with Elizabeth Colbert. It's the story about the Mississippi River, which in the past flooded settlements and towns built on its banks. And you write that the river behaved predictably, but for the developers of the industrialization project, this was not enough. They wanted the river to behave not only predictably, but also consistently. And you think this is a metaphor for our relationship with nature and with life. What does this particular story, a story about men fighting the river, tell us about our attitude towards nature?
So the Mississippi for me is very interesting. So my father's family grew up on the Mississippi Delta. So they grew up in an area that historically would have flooded every season. And when Native Americans managed the relationship with the river, it was that consistent flooding and the need for the river to move and the response of the river over time that they anticipated and they worked with. And so human society responded to the realities of the ways that the river worked. And it was a very sustainable relationship. And the Western perspective as it came into the river was really one of intolerance of the river's predictable features. And so it was a perspective that sought to make the river part of engineering, part of the controlled world. And my grandfather felt this very personally. When he was a small boy, not long after some of the biggest efforts to control the river, he lived in the town of Greenville, Mississippi, which when the river is high, Greenville is actually below the river, but it's protected by a dirt levee. And so the river did what rivers do. The river overflowed the levee. The river overflowed his town. As a small boy, it was a little bit of an adventure, but many people died. And the river was going to do that. It was a predictable feature of how the river was going to respond to our attempts at control. And so for me, that metaphor is powerful because as we think about the future, it's what we try to do with nature again and again. Rather than recognizing the predictable features of nature, we try to bend the natural world to our engineered systems. And when we do that, we create situations where the risk that we confront is much greater. You know, in the context of the river, when the river was overflowing its banks and moving in a natural way year to year, there was a modest risk that was anticipatable of what areas would flood. As we channeled the river, the risk increased and increased. And the more powerful that we felt we were as humans, the more we courted the challenges that the river posed. We built up our cities adjacent to the river, believing in our own power. Even though we knew the river was going to flood if we were thoughtful about it at all. And for me, that's a metaphor for our relationship with nature in general. When we think about our cities, we design them imagining we can control water. We design them imagining we can control the species that move through the air, the species that move on the ground. And we don't have that kind of power. And so we create situations in which the risk is much greater than it was before, and where we're working against nature rather than with nature, and nature is much bigger and more powerful than us.
As you said, when we think of the future, we usually imagine it as a world dominated by man-made technologies with which we put nature under total control. You write in your book that this is a mistake because we can't keep life in check, and also because it goes against our knowledge of nature's rules or nature's laws. I must say that when I read this sentence, I felt relieved, because it's an optimistic vision that we will not be able to suppress nature entirely. But will we actually fail? You know, some experts predict that, for example, AI will become so powerful in just a few years that it will control all of nature, that it will control us and nature as well. So is it really possible that we will not suppress, that we will not control nature completely?
So when you're asking me a question and when you're breathing in, each time you inhale about 1,000 species. And a couple of those species are potentially dangerous. Some of those species are so beneficial that they allow you to survive. Most of those species have never been studied by anyone. They don't have names. We don't understand their genomes. We don't know what they eat. And so even just in the context of our day-to-day breathing, our inhaling and exhaling, we are far from imagining the ability for us to control those species, much less for AI to do it. And so the idea that AI will control all of nature is a kind of hubris that, if you can step back from it, it has a level that's amusing. But at the same time, it's dangerous because it gives us the illusion that our knowledge is much greater than it is, you know? And so for me, when I was a graduate student at the University of Connecticut, one of the studies that really struck me was a study arguing, and I could go into the details, but the take home is it was arguing that there might be 30 million insect and other arthropod species on Earth. And this was an amazing study because at the time, only 1 million species of all kinds were known. And so if it was right, it meant that 29 out of every 30 animal species was not yet named. Realistically, we still don't know enough to say if that estimate is wrong or right. But what's even more amazing is that the recent estimates of the number of microbial species move into the billions or trillions. And so to a first approximation, we haven't even started to name species. And for my field, like, naming species is interesting. We get really excited about it. But even if you don't care about naming species is sort of the first step in having any understanding, any attempt at being able to manage them. And so, you know, when we confront AI, when we look at what ChatGPT can do, when we look at what genetic engineering can do, we feel so powerful and scared of our own power. But the truth is, if we look out at the living world, like, we have a tiny little candle, and most of what is there is darkness. And so, could we imagine an AI that leads to our own demise? That seems possible. I don't have a good enough understanding to understand how probable it is. But the idea that we could develop AI that controls all of nature, you know, it's a sort of quixotic imagining of our power. Is my own perspective, but I mean, I guess the other part for me is that part of what we understand about the living world is understood by a small group of ecologists and evolutionary biologists. And when we're together, we think we're an enormous community. We feel like, you know, everybody knows an ecologist or an evolutionary biologist. But when we look at major discussions about the future of the world, we're a tiny niche of obscure people. And so our voices are very quiet. And so the other thing to me is that when we're talking about these futures, most of what feels obvious to us is not even part of the discussion. And so then if you ask, well, why aren't the AI people talking about the grandeur and magnitude of the living world? It's because there isn't somebody to talk to very often. Often there are fewer and fewer people that see this living world. And we spend more and more time looking at our screens, as we're doing right now, and less time paying attention.
Well, one of the reasons I invited you to talk about your ideas presented in the book is that I think that these kind of voices should be available to many, many people. And I hope that our audience will read the book and follow these ideas. Your argument is this. There are laws of nature that regulate the way certain processes occur in it. And as you said, we ignore the voice of scientists, but we also ignore these laws. We should follow them because only then will nature treat us better in the future. To put it another way, our very existence depends on it. So tell me, why don't we use this observation in our daily lives? Why don't we design solutions following the laws of nature? It should be a simple calculation. Since our lives depend on these laws, we should take them into account in our actions. But we don't. Why?
It's a great question. I think, for one, nature has become more inconspicuous to us. And so we don't see it. When we're planning, when we're sitting, when we're making decisions, if you're thinking about the medical future, you're in a hospital with white walls and you're circumscribed by an invisible nature. And so it's not apparent. I think it also requires humility. It requires recognizing that we can't just control the river of life, to go back to that metaphor, but we have to work with that river of life. And then I think it also, we've spent less, this is a little bit circular, but for various reasons, we've spent less money investing in thinking about those solutions than we have other solutions. And some of the solutions are harder to make money on. And so as an example, one of the ways to manage cancer is to manage its evolution. And so doing so can require fewer medical interventions and less chemotherapy. But that leads to a scenario where you sell fewer chemotherapy drugs. And so there's not somebody who's going to pay for that approach. And so I think very often there's this conflict between those sorts of solutions. Another example would be roach baits have been very successful. So cockroach baits. It's a little bit of sugar, and the roach comes and eats the sugar and also gets poisoned. Well, we could have predicted from in advance that the roaches were going to evolve resistance to those baits in some way. That's the evolutionary law. But there was not much money to be made for making that prediction because it was 20 years off. And so if you're the business making the roach baits, well, you've got 20 years of income before you've got to deal with that problem. And what happened is that the roaches, natural selection was so powerful that it reworked the sensory systems of the roaches so that they perceived sugar as bitter rather than sweet. And so that's an extraordinary power. And we couldn't have anticipated that detail, but we fully anticipated that the resistance would evolve. And so there are challenges related to what we pay attention to. There are challenges related to our hubris. There are challenges related to the ways we invest in the future. And then there are just challenges related to sort of a capitalist framework for the decisions we make.
There are many passages in your book that stimulate the imagination, but one of them is downright chilling. For 2.5 million years, the human population on Earth did not exceed a few tens of thousands of individuals. I have to repeat it. For 2.5 million years, the entire human population on Earth did not exceed a few tens of thousands of individuals. Why was this so? And what does this tell us about natural processes and our potential future?
Yeah, it's a good question. So for that time period, we lived like many other species with pretty modest populations. And there was a time under which there were a period of times when we began to go through these transitions. And those transitions related to our power and our tools. And so one of those transitions was 1.9 million years ago, give or take, when you see an expansion in brain size. Another is about 700,000 years ago. But there are periods in which humans begin to take advantage of a larger and larger proportion of resources. And if you look at a line of our population growth, it looks continuous, but in fact, they're kind of episodes that lead to these new steps. And so for me, historically, just thinking about those evolutionary changes, there are really interesting questions about why did it take so long for those transitions? What was the human brain waiting on? For 1 million years, we used a little hand axe, and that was our only stone tool. Why did nobody come up with a new tool? And so they're really intriguing evolutionary questions that I spend lots of time, with a beer in my hand talking to other biologists about those questions. But I think from thinking about the future, one of the most important pieces there is that most of the ways in which we have changed the rest of the living world have happened in this pulse of time that is, from an evolutionary perspective, so short as to be non-existent. The time between when our population growth really started to accelerate and today is, from an evolutionary perspective, yesterday. And the way we perceive time is in the units of our own generations. And so we think about our childhoods, we think about, a couple of generations back. But if we think about evolutionary time, the entirety of agriculture, of the Industrial Revolution, of the invention of computers, of AI, of lattes, of cities, it all happened yesterday. And one of the consequences of that, there are many consequences, is that we basically still have the same bodies. Well, we have almost identical bodies to what we had 700,000 years ago. And we have very, very similar bodies to what we had 1.9 million years ago. And we've changed the shape of the world around us. And so if we think about stress and fear, stress and fear evolved in the context of living in a forest, living in a savanna, worried about giant snakes, giant eagles, and big cats. Nothing about our neuroscience has changed since we have shifted from worrying about being eaten by big cats to living in a city in Poland. And so we are working at making major decisions about the future using our ancient brains. But it's also the case that we are interacting with the world around us using our ancient bodies. And so our bodies evolved in relation to daily lives in which they were exposed to thousands of plant species, hundreds of thousands of microbial species, many animal species, and that was a foregone conclusion. They evolved in the context of vaginal birth, that each baby was born vaginally. And that may seem obscure to the future, but it turns out that it was in that context that our immune systems evolved. And so our immune systems evolved in light of the dependable presence of all of those species. Our guts evolved in light of the dependable presence of microbes that would be passed from our mothers to us during birth. And so our bodies still work in all the same ancient ways, even as we cast about to change our world. And that for me is it's fascinating, that if we saw Homo erectus from 1.9 million years ago and dressed him up in a nice suit, he would do fine at most of the meetings I sit in. He would just have to nod. And yet we've created this world around us that's so inconceivable in light of that history. And so there's a fascinating part, but there's also a way in which we need to remember that even as for our conscious minds, we imagine ourselves as separate, that our bodies hunger for all of those ancient connections. And so your immune system, if it is not exposed to enough of the right kinds of bacteria, it will overreact. It will cause you health problems. Your brain, if it's not exposed to some natural stimuli from the living world, it will suffer from mental health problems. And so we still need those things, and our subconscious bodies know it, but our conscious brains have forgotten. And so for me, a really important question for the future is, how do we convince our conscious brains of our ancient bodies and the need to reconnect them to the living world? And as a biologist, I can't have that answer, right, of how we do that. But I can pose the question. And to do that, we are going to need social scientists and architects and urban planners and policymakers to help us imagine a future that makes more sense given our ancient bodies.
You mentioned this observation that was so fascinating for you during your studies, that there are millions of species unnamed and unknown. I guess this anecdote refers to so-called Erwin's law. What is this law, and why is it so important, and who was Erwin anyway?
So Terry Irwin was a beetle biologist, an amazing beetle biologist. He died a couple of years ago. And he's the kind of biologist that most people would never meet. His job was to find a particular kind of beetle called ground beetles, which mostly live in the rainforest trees for reasons of quirky nomenclature, and to name them and to categorize them relative to each other. That was his job. He loved it. Nothing in life made him happier than that. And so in order to do that, he found a way to fog the canopies of trees so the beetles would fall down out of the trees, and then he could pick them up like a child at the seashore and find the new ones and name them. And that was enough. But as he started to do that in Panama initially, he found that most of the beetles he was finding were new to science. And so then he started to talk to, butterfly biologists and moth biologists and ant biologists and saying, like, look what I found in the tree. What about these? What about the butterflies? What about the ants? And the other scientists said, well, those are all new too. And these are new. And so it started to become clear that every time he fogged a new tree in the tropical rainforest, most of what fell out of it was new to science. And so he was invited by another scientist to speculate about how many species there might be on Earth. And so he didn't want to do it. He was a beetle biologist. He just wanted to name beetles. That was his happy space. But finally he did it. And he said, well, if there are this many new species in this tree and this many kinds of trees on Earth, how many might there be? And he predicted 30 million species. And for me, on its own, this is a radical realization. It's like Copernicus reckoning with the idea that the Earth is not the center of the universe, because the first thing it tells us is about the grandeur of the insect world. But the second thing it does is it makes humans smaller, 30 million times smaller, because we are just an ever smaller piece of that whole. And if you look back through time, it turns out that this has happened a number of times in science, that scientists thought, well, the world is this big, and in fact, it's much bigger biologically. And after Irwin, it's happened again. And so here the law is that invariably we think the living world is smaller than it actually is in terms of its dimensions and diversity. And we think our own knowledge is bigger than it actually is. And it's been fascinating for me to watch this throughout my career, because at each juncture, I think, well, now we understand. Like, now we understand it's this big and we'll remember. But what's happened in my career is every time I turn around, we've discovered a new dimension to the living world. You know, when I started as an assistant professor, we thought that the bottom of the ocean was dead. That underneath that, you know, if you just dig a hole at the deepest part of the ocean, there was nothing underneath. We now think that 30 to 50% of all living matter on Earth is underneath the bottom of the ocean. And so each time we look, the dimensions expand. And then the other piece to this law for me is that even as we collectively or scientifically understand the expanding scope of the living world, then on a day-to-day basis, we get no better at bringing that into how we understand the world around us in our day. I know that in my office, there are 10,000 species. But it's impossible, and I don't have a weird office, right? I could show you, it's just a normal looking office. But it is impossible for me to remember that in a way that's meaningful to my actions. Even though, I know that perhaps better than almost anybody on earth. And yet I cannot make it real because so much of that living world is invisible. And globally, so much of it is far from us. And so there's this, you know, Irwin's law will stay a law because of our inability cognitively to cope with this expanding living world. I think it's harder than Copernicus's revolution. You know, we could make that switch.
It's exactly what he suggested, that biodiversity is almost infinite. And it's impossible to estimate the size of this infinity. So we cannot embrace this infinity, but we should include it in our thinking about nature. What happens when we include these Irwin's law in our thinking about nature itself and our relationship with nature?
So if we include Irwin's law, I think two things happen. One is it keeps us humble. It reminds us that the unknown is big and can kick us in the ass at any time. I think that the other element, though, is it reminds us that we are going to struggle to manage our relationship to the living world if we do it just in terms of details. You know, if we just try to look at each species around us and manage each species separately, that the unknown is big enough that what we need to do is to understand the general workings of nature and to keep those workings in mind, to know we can always learn more, to know that our knowledge is imperfect, but to know that it's those general workings that we need to be using in planning rather than just the specifics, because the specifics are always partial. And in some places, they're much more partial than others. But we're now in a globally connected living world where what happens in Poland is not disconnected from what happens in the Amazon. And so even if we feel more certain about our knowledge of the living world in Poland, it is the consequences of our actions are still circumscribed by our ignorance about the living world in the Amazon.
You give a lot of very interesting, inspiring examples. For example, the Earth crust is home to microbes whose life cycle is counted in thousands or even millions of years. Their way of functioning is different from anything we know, yet more common than anything we know, because there are simply more of them that we can encompass with our imagination. It's just absolutely amazing example, and it can change our attitude towards nature, and also it can change our image of man as a central point of the world, right?
It can, and there are different ways to do it. We can think numerically. So numerically, the average species is microbial. You know, vertebrates, the entirety of vertebrates, from a perspective of number of individuals or number of species, are a pretty minor component of the earth. But we were attracted to them by our visual, we see them. They look like us in some basic way. They have eyes like us. We can respond to them. But biologically, they're very unusual. To be a vertebrate is a weird, recent thing. But it's also true if we look at the evolutionary tree, and we just think, well, what's normal on the evolutionary tree? The vertebrate branch is teeny. The primate branch is not a branch. It's one stomata on a leaf on a tree. And so then, well, what's more representative of that evolutionary tree of life? Well, it's an extremophile. It's a bacteria that loves extreme conditions. And for me, this, you know, on the one hand, this seems like an obscure point, but we can think about Ethiopia. And so there are parts of northern Ethiopia that are right now almost uninhabitable by humans, where there are hot springs that are also sulfuric. And people can't approach them. Vertebrates die when they get too close. But those hot springs are full of ancient lineages of life that are far more normal from an evolutionary perspective than vertebrates are. And to me, what's amazing about them is that the worst things we can imagine doing to Earth from a human perspective are probably going to benefit them. So a hotter Earth they would like more. A more sulfuric Earth they would like more. Some of them would like an Earth that's more covered in oil spills. And one point of reckoning for me in that context is to realize that what we're talking about when we talk about the end of nature, and the end of nature is not the living world as a whole. It is not the rules of nature. It is the end of a nature that is permissive to our existence. It is the end of a nature that will support us. It is the end of a nature that is appropriate for human thriving. That nature itself, in the bigger sense, you know, most of what we can imagine today as our worst things, there are species that will love it. There are species that will thrive. And it was interesting at the beginning of the conversation, you remarked that some parts of that felt hopeful to you. And they feel hopeful to me too. That to know that the processes of nature that I find to be so beautiful, so inspiring, that they're bigger than our power. At the same time, there's obviously a foreboding reality there, which is that with our changes, if we don't pay attention to the living world, what we threaten is our own wellness. What we threaten is our own species and the species we most like. And in some ways, that's a subtle term, but I think it's a term we need to reckon with. That the nature that is threatened is the nature that will sustain us. And so how do we imagine natures in the future that will continue to allow us to thrive when we can't, for the most part, change our bodies? We can't change our ancient connections to the rest of the living world. And so that is a core piece that we start with in any plan we want to make for what that sustaining nature would look like.
In the future, we are going to experience an unprecedented migration of species driven by, for example, climate change. And as you write, homing will become the most important ecological phenomenon of the next centuries. or even millennia. Homing in this context means the process of settling a new place by a species. How will this affect our lives in the future?
So many different ways. I mean, so one way to, so if we think about this uncountable number of species, so just to take an example, most of the species in the tropics are going to be moving with climate change. They are going to move somewhere. And we can predict more or less where they are going to need to move to thrive. Ecologists have honed our ability to do this, thousands and thousands of papers. We debate about the minutiae, but the core piece we understand. And so some of those species are species that benefit us. And so I live in North Carolina. Right now, we can't grow mango trees. In 10 or 15 years, we will be able to grow mango trees. And so that's delicious. I will appreciate that part of the future. But it's also the case that there are pathogens of humans that will be homing in on the place I live. It's also the case that there are pathogens of crops that will be homing in on the place I live. And then there are many, many species that we've never studied that will be homing in on the place I live. And so there are predictable features there. We understand which pests and pathogens are most likely to move. And in my own state, it means we need to change our public health measures. We need to do more spending to be ready for the new mosquito vectored pathogens, for example. We need to do more spending to get ready for tropical pests of our crops. And we know that is going to happen, and so we can ready ourselves. But we also know that the uncertainty will increase because many of these species we've never studied. And so we also have to be ready to anticipate a new uncertainty. And the same thing will happen in Poland. You know, that there are things growing, and there are crops right now in Poland that are going to need to home by moving north. You know, some of Finland's future crops are current Polish crops. By the same token, wine grapes are going to do better in Poland by the most recent models I've seen. And so there's an opportunity, but we need to think about it at the big scale. This is not just a few species. And so we need to ready for that movement. And we also need to think about which species we are helping to move. Because the way that we help species to move, I mean, some species we carry them, you know, gently. We will move the panda, for example, by hand as it needs to move. We will replant its forests. But most species, the way that we help them is by creating corridors of the habitats through which they can move. And so there's a lot of work in Europe, as in North America, to create those wild corridors. We need to do it faster. That's going to help some of these wild species we benefit from and help our forests work to move. But it's also important to recognize that we've created default corridors. And so which species are we allowing to move most readily right now? Well, by connecting all of our agricultural fields, we make it very easy for crop pests to move. They move before we blink. You know, some have already moved into Poland. I guarantee there are new crop pests in Poland. It's also true by connecting our cities that the species that live in our houses and in the gray spaces of our cities, we make it very easy for them to move. And so by those seemingly subtle choices about our landscapes, we're actually making big decisions about which species do or don't move. And so as you think about the future of Polish cities, how do we reimagine them so they favor the movement of the species that are going to benefit Polish people? And how do we think about disfavoring those species that we know are going to cause problems, or just being able to anticipate them? And, you know, as humans, our default response to these changes is to wait until there's an emergency and then to respond. And as I think COVID taught us, it doesn't work very well. But we can anticipate a lot of these changes, but it means we need to make the requisite policy changes now. You know, it needs to be happening now. And one of the most exciting things for me about writing this book and thinking about these changes is I think there are a lot of people eager to make these kinds of changes. I think there are architects who are excited about reimagining our cities, and urban planners. I think there are policy people who want to make these changes. And so I think we're in a moment when we can be bold. And it's not going to be every place, but can you work together with your city, your place, to be part of the world that is anticipating and acting to yield a better future in light of a better imaginary? I think it's very possible. It's going to be patchy, but we can do it.
Another example you present in your book is about violence and temperature. People are more prone to violence when the temperature rises, but not the temperature of emotions, the temperature of the air. Why does our propensity for violence increase in warmer climates?
So it's a great question. So our bodies evolved in the context of very specific temperatures to have both a physiological limit. So there is a temperature beyond which your body fails, but there's also a comfort zone. And it turns out that before we get to our physiological limit, those temperatures at which the body begins to fail, we see cognitive limits begin to approach. And so part of what's happening with violence and temperature is that the brain's ability to actually process a situation is declining. That you're less comfortable, the frontal lobe is just doing a little bit less work, and there's just a greater proneness to an aggressive interaction. And so, for example, there was a great study in Arizona a number of years ago where they had people pull up to a stoplight, and at different temperatures, and they would just, even when the light turned green, they would stay there. And they would see how long it would take the person behind them to get very mad. And this was in a kinder, gentler time in the US, but when it was less likely they would be shot. And what they saw is that the hotter the temperature outside, the faster the person in the car behind them would get out of the car and start a violent interaction with the person waiting at the light. Now, I assume these were graduate students. This was a very bad project to have to be part of, but it was very illuminating because that outdoor temperature changed that reaction. Now, if you imagine a whole city, that's scaling up across a whole city. And so it leads to these changes and interactions happening all over the place. And then that's superimposed on top of other things. And so when it gets hotter, police are less likely to go out and do their work. Other services are less likely to happen. And so you have a little bit less policing in the city. When it gets hotter, the odds that you get other sorts of problems in society increase. And so in any given, there's a version of this for an individual interaction, but that in any given place, that's then connected to these broader phenomena that increase the propensity for violence. And this begins to happen at a temperature cooler than people are most worried about. And so I would say for me, it's amazing that cities ever work, that we're ever kind to each other in cities. It is a testament to humans and our ability to be together and to find ways to work together. But if at these higher temperatures our propensity to violence and to violent interactions of many kinds rise up, that we're going to need to find ways to anticipate that and find ways to work together to keep that in mind as we plan cities. But it also means that there are just places that are going to be more prone to violence. And we need to think about what's happening there. And so Sudan is an interesting case right now. The details of what's happening in Sudan relates to the details of Sudanese history, colonial history, the history of these two leaders, but it's superimposed on a country that is getting hotter and hotter. And where crops are more likely to fail, and you're at the margins in many ways. And so it's not to say that the history is unimportant, but this additional pressure from rising temperatures has the potential to take something that might not have become violent to something that's much more likely to become violent. And so I think one of the questions is, what do you then do about that? At a city level, you can think about how to have anticipatory public health systems. You can think about how you warn people on these hottest days. I think globally, it also, though, means that we need to to take extra care in thinking about those countries that are going to be hotter and hotter and how we respond to the crises that emerge in those countries. Because they're going to be superimposed on these long-term changes that are going to make peaceful interactions harder than they were in the past. And so what sort of policy, what sort of geopolitics do we need in light of that recognition? And one of the things I found is that because in academia, we work in scholarly bins. And so the economists work over here, the climate scientists work over here, the psychologists work over here, that it hinders our ability to plan together. And so on the one hand, India and Pakistan and their border will be another area that the probability of major problems in India and Pakistan in light of climate change is essentially 1. It will be much hotter, and this will create escalating problems. But if you look at predictions of economists would say, well, the GDP of India is increasing, and there are lots of positive trends. And we need to wed those things. We need to connect our understanding of the economy with our understanding of the climate that's coming, because if we do those individually, we're going to make the wrong decisions. And so it has to be part of the portfolio of things we understand in each of these cases. And then the other reality is, if you think about a country like Sudan, Sudan is basically not contributed to climate change. I mean, except for selling oil, but even there, it's a minor relative to the global story. And yet they are going to bear much more impact, 100-fold more impact than the United States that's contributed, an enormous part of our climate change to date. And so how do we think about our responsibility to Sudan in light of what's happened there? And if we just focus on those two leaders and the war, we say, well, it's a political issue, it's a historical issue. But if we say, well, this is partially to climate change, we also then have another kind of culpability. And how do we think about that culpability in that situation? And we are going to enter these phenomena, whether or not we talk about them, whether or not they're part of our policy landscape, whether or not we prepare for them. And some place like Poland, the mean annual temperature in Poland, on the average day, most of the year, you won't face these temperatures that create these situations. But a few days of summer, you may, and so there is the potential in a Polish context to be anticipatory there too. It's not a good day for a good big football match, for example, when you're superimposing these potentials for violence. My sphere of expertise is literature. So I'm very interested in how biologists perceive literature. So from a biologist perspective, what is the human need for storytelling? How did we come to develop this skill, and why do we continue to develop it? I love that question. For me, on the one hand, I'm somebody who thinks about the rules of life. And so I think about rules. But on the other hand, we can only make sense of these rules by telling stories. And I think there's a book by Robert Kaplan out right now about tragedy and literature. And it's a very interesting book. And one of the arguments he makes is that in the US, we're now in a generation where the number of people who've had firsthand experience of geopolitical tragedy is very few. And yet tragedy is a part of how we make decisions globally. You have two different goods, each of which has a bad element. How do you think about the decision-making process? And his argument is that the best option for people in that context is to turn to literature and to use the ways in which literature tells us about tragedy in the past and allows us to think about the actions of individuals in light of tragedy, to think about the decisions we make in the future. And I think that is one way that literature, if we fail to rely on literature and thinking about the future in that way, we will miss an opportunity, and and we will deal with each challenge as though it's a new challenge, as though no one's ever dealt with it before. But I also think that humans respond to the world in light of stories. Stories in which they can see themselves. Stories in which they feel themselves reflected. And I think sometimes when we're dealing with these big challenges, one of the things that's paralyzing is we can't see ourselves in the stories of people who made decisions. And so we are left with nothing we can do. And so how do we tell stories about the future that allow us to see the multiple futures that are possible and the ways in which we can be like a protagonist that acts toward a future that we want? And one of the things I've been trying to do, and I'll say that I feel deeply my own limitations in terms of my ability to think about different futures. You know, what's the portfolio of futures that we can think about, and which one should we be working toward? And so we're starting a new project to work with science fiction writers, with speculative fiction writers, and to pair them with scientists to think about how do we tell the stories of future worlds through literature so that we can then get policymakers, city planners, architects to respond to them, to have a context in which to react. And so for me, I think literature probably has, if not the most power to help us make better futures. I don't, if it's not literature or art, I don't know what other field can more help us in this moment. And I think an example of a failure where we failed to involve literature relates to the climate change scenarios. So scientists, by and large, made these climate change scenarios that relate to different levels of emissions. Well, emissions is this extraordinarily abstract thing. It's how much greenhouse gas we're putting into the air. We can't see it. It relates to our daily lives in no way. And so people cannot see themselves in these emission scenarios. They're impossible to relate to. And so we've asked people to work toward this emission scenario relative to that emission scenario. But they're not complete futures. They're not even complete pasts. And so people can't do it. Like, it's just impossible to work toward 3 or to work toward 2. It has very little meaning. And so I think a very exciting question for the writers of the future is, how do we work together to tell stories and to lift up stories that can help us make these decisions? And how do we work together to lift up the power of literature as it helps us in these decisions? And right now, for a lot of people, I'll stop there.
Rob, thank you for this inspiring conversation. I encourage everyone to read your book, because it really stimulates the imagination and allows us to change the way we think about our position in the world and our relationship with nature. And I invite you all to watch the next episode of Nature of the Future. My interviewee will be Catherine Liu. Remember the date, the last Thursday of June. Rob, thank you again.
What an extraordinary pleasure.